Alright, hell yeah. So we're going to do some math. This is JEE Main 2025. All these problems are math. This is the first one you come to. This is basics of mathematics. I don't know how basic this is. Here's our equation. We have e to the 5 multiplied by log e of x. That quantity squared plus 3 is equal to x is equal to 8. And so here's the solution, because I didn't do this right. We can go over kind of methods that I explored. But they're just going to take the natural log of this side and the natural log of that side. And one way you can do it is you can write natural log of e to all this stuff. And I'm just going to put all that stuff in parentheses. Or you can write it as log e of this value e to all that stuff in parentheses. And I think it is useful, especially with logarithms. This is your base, and this is kind of your value, and this is going to equal an exponent. And how do we set it up? We set it up like this. I'm going to say a base times an exponent, or a base to an exponent, and I'm just going to put it into a box, is equal to this value. And in this case, this value is e to that. And I also do this. If I'm going to have this logarithm, log e, and then just all this stuff in parentheses, and this is going to equal, I'm going to say, hey, this is the box. And I think that's useful. There it is. And this is going to equal, obviously, that side. It's an equation like that. And how do we set this up? Again, we take our base to this exponent is equal to this value right there. And it just happens to be that value, and then because if we took the log e of actually this entire thing, then this entire value is e to these two parentheses inside. And now we can easily see that this box is equal to that stuff inside. And so that's how we get. So if we take log e of all of this, knowing that this is e to the this stuff, and then this side is log e to the x to the 8th. And this is also written as natural log of this stuff. You could write your base in natural log. Just remember that it's a base of e, but that's not going to be written out if you do the natural log, just ln. But this log e is the same thing as ln. So anyway, so all this stuff comes down, and we get 5 parentheses log e. And then they even do this. If this is log e, might as well make our life simple. This is just ln x, and then so we're just looking for these values of ln x. And once we get everything kind of downstairs on the same level, then we're going to notice that we have an ln x squared and an ln x right here, and then a constant, which is very similar to a2x squared plus a1x plus a naught. A naught is our constant. A1 is this value on this value of 8. Our x is ln x. Our x squared is ln x squared. And so that's kind of what we have. Hell yeah. So cool. We're going to bring this stuff down. And so we have 5 ln x squared plus 3 is equal to, and then this side, we're going to have ln of x to the 8, and then we got to kind of do that same thing. Maybe it's useful to write this out again, that it's log e of this value, x to the 8, and here this isn't e to the 8. You know what I mean? So how do we know that we can bring this 8 outside? Oh, well, let's set it up. We know that this whole thing is going to be our box. And so this is the value, and we have a base of e to an exponent, is going to equal this value, x to the 8. And so what we could do, all right, hell yeah, I got stumped a little bit, but this is a function where we can input any value of x we want in, and I don't know, just like a lot of equations, just throw some values that are the easiest to work with. And so if I make x e, so I'm going to say for this function, x is equal to e, and I'm going to have e to the 8. And then what is this? So this box is equal to 8. So this whole thing is equal to 8. And now we know that if we have ln x of 8, we can maybe bring that 8 outside. And I'm not even doing a good proof of this, but now we have 8 ln of x. And so let's set this up. This is going to be 8 log e of x. Here's my log e of x. So this entire thing is going to equal my base e to an exponent is equal to that value of x. Again, I'm going to say x is equal to e to the 1, and this box is now equal to 1. Cool. And so this is going to be 8 times 1 is equal to 8, and that's going to be the same value. This 8 times 1 is equal to this value of just 8. And so we kind of have a check on reality there. All right, hell yeah. Cool. So we have simplified it down to 5 ln x squared plus 3 is equal to 8 ln x. So let's write that. So we're going to have 5 ln x squared plus 3 is equal to 8 ln x. Let's get everything to one side. And then what they're going to do, let's follow what they do. They're going to set another variable, t. You know, it's kind of like a u substitution, but we're just going to change the independent variable to now t. And we're going to say t is equal to ln x. And so this is going to be 5, I'm just going to write it as 5t squared plus 3 is equal to 8t. Now I'm going to get everything over here. So I'm going to have 5t squared minus 8t plus 3 is equal to 0. And I think that sometimes it can be too confusing to use another letter. You know what I mean? So let's just, I don't know. I mean, let's say this x, and I'm not going to put any subscripts on it, but x is represented as t. And let's just go back to using it, even though that's not what you want to do. You want to get used to using different letters because this t is ln x, and the x is just this independent variable. But hell yeah. I don't know even why I'm doing this, just because I'm telling you why. Because visually, I'm going to make less mistakes if I just see this variable as x than if it's t. I'm not used to that. That's the reason why. Hell yeah. Now I'm going to divide everything by 5. 0 divided by 5 is still 0. So we have x squared minus 8/5 x plus 3/5. Now, since we have this coefficient as 1, we should be able to factor this. Now we look to this term and find factors of it. If it was 9, we could be like 1 and 9, 3 and 3. Those are the factors of 9. What the hell are the factors of these? I never even thought that you would actually do 1 and 3 and then 1 and 5. And then you could have different factors of, you could have that times 3 and then yeah, that's new to me. Hell yeah, I think that's sweet. And you can have this. You could have 3 times 1/5. So you could have 3 times 1/5, or you could have 1/5 times 3. Those are the factors of this. And, you know, there's more. You can also have 1 times 3/5. Hell yeah. And then if you can have And then you want to make sure all your denominators are the same. So if you did have 1/5 times 15 fifths, and if you did have 15 fifths times 1/5, and if you did have 5 fifths times 3 fifths, these are your three combos. What you're looking for is that if you ever added these, so we multiplied to get that, if you added these together, you know, plus or minus either one of these, you need to get 8 fifths. So 15 minus 1 is 14 fifths. That doesn't get us there. This one's about the same, exactly the same. And this one, if we did, you know, 5 plus 3, that's 8 fifths. So might as well do -5 minus, or you would do -5 fifths plus -3 fifths, and you would get that -8 fifths. So there you go. So we can factor this. So I think that's useful, especially in test scenarios, to be able to do it that way and be like, hell yes. Now we have x is factored twice, and we're gonna we need to make this positive, so it's negative, and this is gonna be 5 fifths, and this is gonna be 3 fifths. So that's what we saw there. These two add, so we're gonna, you know, foil this. We're gonna have an x squared. We're gonna have a -5 fifths x plus a -3 fifths x. That's 8 fifths x, and then we're gonna have these two terms multiplied. The negative becomes positive. The two negatives become positive. 3 times 5 is 15. 5 times 5 is 25. Divide by a factor of 5, and you get 3 fifths, which is that. Hell yeah. So here is our solutions. Our solutions is x is equal to 3 fifths and x is equal to 5 fifths. 5 fifths is just 1, so x is equal to 3 fifths and x is equal to 1. Hell yeah. So now what we want to do is go back and then, so now let's go back and put in our value of t so we don't lose our brain. But now, I mean, we can just change all these things to t, and we did it. For this video, you could use quadratic equation. I got to work on making shorter videos, and I already got a solution to that. I'm not going to do it 3 or 4 times, but hell yeah. So now we have t is equal to 3 fifths and 1, and we said that t is equal to the natural log of x. And we want to know what x is. And it shouldn't be too big of a deal to go back and forth. Even write this out as log e of x, and maybe it is a big deal to go back and forth. But hell yeah. So let's just throw in our first value. 3 fifths is equal to ln of x. How do we get... yeah, that's crazy. I don't know. You know what I mean? Like, what do they do? And that's where I don't like just using, so if I have ln of x is equal to t, I think it's just that you just do e to both sides. If you do e to both sides, then you have e to the 3 fifths is equal to x. But that sucks that I can't even explain. This would be at least log e of x. This might help out. This value... What is this value again? So box it in. We're going to say this value is e to an exponent is equal to x. Okay, does that even help us out? Probably not. Not really this way. So it's a head scratcher. But anyway, I'm just going to go on, try to make a better video. That's where my limit is. I don't know. You know what I mean? E to the natural log of x, it just brings out that x. Cool, that's all I know. Okay, so our equations are t is equal to natural log of x. So we have 3 fifths is equal to the natural log of x. E to both sides, and now we have x is equal to e to the 3 fifths. Second solution, 1 is equal to the natural log of x. E to both sides. Now we have e to the 1 is equal to x. So our two solutions are x is equal to e, and x is equal to 3 fifths. It wants to know the products of the solutions, and so this is e to the 1 times e to the 3 fifths. This is also e to the 5 fifths times e to the 3/5. When you multiply these together, if you had e to the 1, e to the 2, this is the same thing as e to the 1, e to the 1, e to the 1. There's the e to the 2, there's e to the 1, and we get e to the 3. What did we do to these? We did e to the 1 times e to the 2 is just e to the 1 plus 2. You might have to throw in different values just because sometimes e to the 1 times 2 is the same thing. You know what I mean? But that's equal to 2, and that isn't equal to e to the 3. So anyway, so we're just going to add these. So we're going to go e to the 5/5 plus 3/5, and we get e to the 8/5, and that's the answer for this problem. The answer to this problem is e to the 8/5, and I think we did a good enough job of going through that. If you got this quadratic equation, you could just do negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's do that fairly quickly. This is going to be 8. Because b is negative 8, negative of negative 8 is positive 8. Hell yeah. Plus or minus the square root. We're going to square this negative number. That becomes positive 64. Minus 4, 5, and c is 3. So this is 20 times 3. That's 60. Negative 60. You know what I mean? Or just this is 60 and we're subtracting a 60. So we have the square root of 4. That's going to be 2. So we have, and this is all divided by 2 times 5, which is 10. So we have 8 plus or minus 2 divided by 10, which is going to be 10 divided by 10. Cool, check. And then it's going to be 6. 8 minus 2 is 6 divided by 10, which is 3/5. Check. So those are our two answers. That was solving for t, and then we have to sub it back into this equation where we have, and then just know that this equation is x is equal to e to the t. That's how you go from those and those. So hell yeah, good enough. I made a video. I did it pretty decently fast. So thanks for joining me on this one. Booyah.